Hi there, it's Jason Gorman from Codemanship with the sixth and final video in our series on test-driven development in Python. In this video, we're going to be looking at test doubles. A test double is an object that is used by the object or the function that we're testing that for whatever reason is not the real thing. Typically, we use test doubles to pretend to be external dependencies like databases or web services, so that we can write fast running simple unit tests for our code, for our logic, without actually involving the real external dependency. The example I'm using here is a video library, and we're testing the functionality for adding movies to the library. And we have a requirement that involves an external dependency. And that is when we add a movie to the library using the IMDb ID of that movie, it actually looks up the information about the movie using the IMDb API and then adds that to the movie when it's added to the library. Now, we don't really want to write a test that connects to the IMDb API because that will make our test code more complex, and it will also mean that the test will run slow. And we want our tests as much as possible to run fast, to be real unit tests. So we can use a test double called a stub. Stub is a test double that returns test data. From the outside, it looks like the real source of the information. It is our gateway, if you like, to the IMDb API. But what we're actually going to do is we're going to hard code that in the test so that our stub, when asked to fetch the movie information, will just return whatever information we tell it to. So let's start writing this test. I'm going to start by writing the assertion first and work backwards. And in this case, what we're saying is that the IMDb API is going to return a dictionary of information that we can use about our movie. So let's imagine that we have a dictionary of information. And what we're saying is that should be attached to the movie when it's added to the library. So working backwards from here, what is this information? Well, it doesn't actually really matter. We can make it realistic if we wish and say it's going to look like this, but it doesn't actually matter what the data is because it's all make-believe. This isn't real data. It's not really coming from IMDb. All we care about is that this information is assigned or attached to the movie. So we don't need to worry at this point about what the information is in our test. If you want to define the shape of the information just to document that, then by all means do make it realistic. But it is actually made up data. So what we're saying is we're assuming this is what will be returned. It doesn't matter if this is what's returned, just as long as it is attached to the right movie. Okay, now the movie is going to be returned from the library. So once we've donated this movie, once we've added this movie to the library, then using the IMDb API, so let's create an empty library to begin with, and then we're going to donate. So let's just have a donate method, donating movies to the library using the IMDb ID. So that's all we need to tell it, and it will look up the rest. So now again, it doesn't actually matter what the real ID on IMDb of the Abyss is. We're just making this up. This is all make-believe. What matters is it's the same ID that the movie is added with. And that's our movie there. Forgot to do that. Okay, so what will happen when we donate a movie to the library is that movie will be added to the library's collection of movies with this information about the Abyss, about this particular movie. Now, where is library going to get this information from? It's coming from some external source. So we need some object whose job it is to fetch this information. Let's imagine that this thing exists. Let's call it an info source. And actually, no, we can just... And it will return whatever information we tell it to return for the purposes of this test. Now this info source stub, it's going to look like the real thing from the outside, but it's actually test code. It's part of the setup of the test. It allows us to define what the test data is. Let's assign that to a field. And all our stub needs to do, when asked, is return whatever information we tell it to return in the test. That's its job. As simple as that. That's all a stub needs to do. Return whatever data we told it to return in the test. That's part of the setup of the test. Okay? And notice that we're passing the stub in. So this is dependency injection. And that means in our library, we will be able to substitute a stub for the real thing or a real thing for the stub, as we'll see later. So that mechanically is how stubs work. They work by dependency injection. We're not passing the data in because the data, it's not our data. It has to come from some other source. So some object somewhere has to speak to another object whose job it is to fetch this information. And that's, in our test, that's the stub. Let's create our donate method. Don't know why I've got 3 params there. I think I know what I've done here. Yeah, I'm creating that in the wrong place. We could do it there. That would be absolutely fine. But it would be more convenient, rather than have to pass it in over and over again every time we donate, to actually pass it in the constructor to the library like that. So my little mistake there. Okay, now, if we take a look at our objects here, these are data classes. This is a new thing in Python. Don't need to worry too much about data classes, except to know that when we define fields for a data class, then we can define them in this way, and it will automatically at runtime generate a constructor that should match these fields in terms of type and order. Now, we need to declare this as some kind of object, but we want it to be easily swappable. So we can't declare this as an info source stub, because that means that's the class, the instance of the class that we'll have to pass in will have to be the stub. That's not what we want. We want it to be swappable. So let's make it as general as possible there, so we can inject any kind of object in there. We could be more specific and create a base class, an abstract class for the stub, if we want it to be totally type safe. So let's call it info source, for example. This is not necessary in Python. We don't have to do this, but let's do it anyway. And what we're saying is it has this this signature for fetch info that matches like that. And we could, if we wish, say at the bottom here that our info source stub inherits from info source. And then we can make it a bit more strongly typed in our constructor here that it has to have a method that has that signature. Now, of course, Python won't enforce this. There is a built-in library that we can use to enforce it a bit more cleanly, but actually Python will not enforce this. But it documents the fact that this is what it really looks like. So anything that implements fetch info needs to have that signature. So it's really just documentation, and it's quite popular with a lot of teams to document it in that kind of way. But in Python, we could have just easily just said it's an object. Okay, so we have our donate method there. It currently doesn't do anything. And we should at this point. Now, here's the interesting part. If I try to run this, we're going to get a bunch of errors. There we go. Let's just take a look at which tests are failing. Both tests are failing. Let's take a look at the first test. Because now we've changed the signature of our methods, movie now requires an info source. So we need to pass something in here. Now it can't be that. Well, no, actually, probably in this case it can be that, because we're not actually adding a movie. Okay, so we're passing in something. This is what's called a dummy. It's another kind of test double. So we have to pass in something for that parameter. And in this particular test, because that fetch info method is not going to be invoked, we can pass in none, and that will work, hopefully. Nope, wrong one again. I'm mixing up my constructors. So that one there. So that can be none. And now this requires information about the movie, in which case an empty dictionary would be fine. In fact, could also pass in none, because the information in this particular test doesn't matter. So these are both dummies. They have to be there so we can run the test. Hopefully that test will start passing again. No, still missing something. What else is missing? In it takes two positional arguments. Where? Our movie, yes. Our movie requires information. So we need to add that to our constructor. And in this case, it's just going to be a dictionary. Now our signatures should match. That test should now be passing. Lovely. Okay, we're back in the room. Everything's ready to go to write the code to pass the second test. And what we need to do first of all is we need to create our movie, give it the right ID, and now we need to fetch this information using our info source. Nice and strongly typed there using the IMDb ID. And that should insert the right information, the information we told the stub to return. And then we add this to our movies collection. Okay, and that's all passing. Lovely. So that's a stub. A stub's job is to return test data. Usually it's data that comes from some external source, although there are other reasons that we might use stubs. So data that might come from a web service or data that might come from a database, so that we can unit test our core logic without directly involving these external dependencies. So from a unit testing point, they are very, very useful. And we've also taken we've taken a look at what are called dummies. Dummies are very often used in our tests because we need to put something in a certain place. We can't just have it be blank, and therefore we have to provide something. In this case, we're providing none because the dummies are not actually being used. If those objects were used, if their methods were invoked, we couldn't pass in none, so we'd create what's called a null object, which is an object that has the interface of the object but doesn't do anything. So that's another example of a dummy. So that's a stub. A stub allows us to provide test data that will come from some other source, usually an external source. Other reasons why we might use stubs is when we have a test that involves data that is changing, for example, date-driven logic. So we might decide to provide a stub, for example, to calculate a person's age, so that their age in the test is always exactly the same. So that we don't have with a situation that one day the clock strikes midnight and a whole bunch of our tests start failing because that driver, for example, is now no longer under the age of 25. So they can be used for that and also for random data as well. And there's something else we can use stubs for that is very, very handy from a work perspective, and that is we haven't actually written the code to connect to the IMDb API yet. So what we're doing here is we're faking it until we make it. We're faking it until we make it. And that can be a very, very powerful thing because it allows us to essentially break our solution down into meaningful chunks, and we can test drive one part before worrying about the next part. So we essentially make it someone else's problem. It might be our problem in the future when we get to it, but this means that we have really good separation of concerns. And we have that because we take a look at the code here. We're injecting our stub into the library so we can easily substitute different implementations with it. And from an architectural perspective, this gives us a lot more flexibility. The stubs are not just useful for writing unit tests with external dependencies. They're also very useful for creating a clean separation of concerns between, for example, the problem of adding movies to the library and the problem of fetching information from IMDb. fetching information from IMDb is somebody else's problem. We don't need to know how that works, but we have defined from the outside what it will look like. So it will look like this. We will use it like this, and we know what to expect in terms of what it will do. So we've defined a part of our system that doesn't exist yet from the outside. So going back to our jigsaw puzzle, if we're constructing a jigsaw, what we're doing here is we haven't got the piece yet, but we've defined its outline. We know exactly what shape the piece has to be in order to fit into this jigsaw. And this is very, very useful because it allows us to work from the outside in on complex multi-layered designs and essentially write tests for one layer or one part of our design and fake it until we make it with the other parts so that we are defining externally what their shape is, how they will be used and what they will do, but we leave it till later to worry about how they will actually work, or we might even be leaving it to someone else to worry about that. So this is how we scale up test-driven development. On more complex designs, we don't have to solve all the problems at once. And we can work from the outside in, defining the pieces of the jigsaw externally. What do they look at? What do they look like on the outside, and what do they do on the outside from the client perspective, without having to get to those parts yet. The time will come when we have to write code that will actually connect to IMDb. And for that code, we will repeat this process. We will write unit tests for that part of our solution. Um, and so we end up with unit tests for our library for donating a movie, and we'll end up with a set of unit tests for fetching information from IMDb. So we're kind of getting the best of both worlds here. We're working from the outside in, so we end up with pieces that are guaranteed to fit together at the end. But we're also driving tests at stages within layers in our architecture, so that they're much better at pinpointing exactly where problems are. We're separating those concerns and writing tests for each of those concerns, so it's much easier to figure out where it's gone wrong when it goes wrong. So a very, very powerful technique here. Now, there's another instance where we might have an external dependency, but this time no data is being returned. And in these kind of tests, what we're concerned is whether or not a message was sent, whether or not a method or a function was called. So we have a second requirement for our donating movies to this video library. And that requirement is that when a new movie is added to the library, we need to email the members of the library to tell them about this new movie. So we're going to be writing a test using a new kind of test double. We've looked at stubs, we had a quick look at dummies, but what kind of test double can we use to test that a method was called? And to demonstrate this, let's start writing this test. Emails sent, emails members about the new movie. Okay, so there's going to be an external email system. It doesn't exist yet, as far as I know. And so we're going to fake it until we make it. But what we need is we need an interface to pretend so that we can pretend we're talking to that system. And let's call this emails. And we're imagining that it has a method called send mail. And what we want to verify is that this method send mail on this emails object was invoked, and it was invoked with certain parameter values, assert called with. You'll see what I'm doing in a minute. And we're saying it should be invoked, and the first parameter is going to be the name of the template for the email that we want to send. And the second parameter is the distribution list that we're sending the email to, all members. And the third is the information about the movie that we want to send it with. So there's our movie information. Okay. Now, let's do that there. Now, remember, it doesn't actually matter what the information is. An empty dictionary is fine. Now, what is emails? Emails is going to be, let's imagine we have an email system. There's an interface and abstraction that we're defining here. And what we're going to do, we don't actually want to talk to the email system. This is going to be another test double. It's not going to be the real thing. Is we want to say, okay, what I want you to do is I want you to remember if this method is called. Remember if this method is called and remember what parameter values it is called with. Okay. So this is the built-in functionality of the unit test framework I'm using to allow us to create these things called mock objects. A mock object is an object that allows us to test whether an interaction between two objects takes place. What we do is we mock individual methods of that object so that when that method is called, it will actually remember what parameter values it was called with, so we can assert later whether it was called with the right parameter values. Now, okay, now we need our library. We can't have a null object now for returning IMDb information because that method's actually going to be invoked. So let's make it not null. So we'll use our stub again, but this time we're not necessarily using it for that purpose. So it's our info source stub. It can't be null, but we don't really care about it, but we do need information. And let's tell it to return the info. Doesn't matter what the information is, it's not important. And now we need another object whose job it is to send emails, and that's going to be our emails subsystem here, our mock object. Okay, so let's quickly go back and change the signature of library now so that it also has, and that's going to be of this type, our email system. I think I've got to, yeah, that needs to be declared above. So let's do this. I do find Python a little awkward sometimes. All of these, of course, need to be at some point extracted into their own files. But for now, and on our, did we say send or send mail? Let's take a quick look down here, see if we got it right. Send mail, so it should be that. So we're going to find this on the interface here, and it's template, the distribution list, and the info, the movie info. Okay. And again, this is just an abstraction, just defining what this thing looks like. Okay. But this time it will automatically generate its own version of sendmail that remembers when it's invoked. Okay, so there's our magic mock library, and we need to donate our library. And again, it doesn't matter what the idea is because we're not actually concerned with that. What we're concerned with is whether or not send mail is called, whether or not it's invoked. And if we take a look, it will say, hopefully, emails. Yeah. Back again to our first test there. So what we're saying here is we also, again, we need to provide something here, and it can't be null because that method is going to be invoked. So what we're going to do is we're just going to provide another mock implementation. In actual fact, no, that's fine. We can just do that. It will call that method and nothing will happen, and that's absolutely fine. So that's another kind of dummy. It has to be there. And there again, when we find a movie, we're not actually sending an email, so that can just be none. Okay, now hopefully we should have 2 passing tests and 1 failing test, and our test should be failing because that method is not called. Expected call not found. That's what we expect to find. So that's our failing test. And all we need to do to pass this test, when we donate a movie after we've done the main piece of work, is call send mail and specify that it's the new movie template that is being sent to all members. And we are using the information for the movie in that email. And that should be a passing test. So that's a mock object. It allows us to test that a message was sent, that a method or a function was invoked, and we can test what parameter values that it was invoked with so that we can design that interaction from the outside. It's an external system, an external dependency, and what we've done is we've defined what that interaction will look like from the outside. So very similar to what we did with the stub, but this time we're sending information. So you could say this is command and query. So this is a command, and this is a query. And so stubs are used for faking queries, and mocks are used for testing commands. Commands typically that would involve external dependencies, so that we can test that our code works, that we actually call that command or we send that message without actually connecting to the email system. And again, this email system doesn't exist yet, so we're faking it until we make it. But we have defined from the outside in what it looks like and what it does. So we're able to drive our design using a mock object from the outside in. Notice the mechanics of this dependency injection. Our info source and our email system are being injected into the library in the constructor, which means we could replace that info source implementation with a different implementation very, very easily, so that we can stub and we can mock, but also so that going forward, if, for example, we decide to use a different email system or handle emails differently, maybe instead of sending the email straight away, we stick it on a message queue, it'd be very easy to do that now without having to rewrite the logic of the library. And it'd be very easy to replace IMDb with another source of movie information like Rotten Tomatoes, again, without rewriting our library. So because we've got this nice clean separation of concerns for testing, for unit testing, we find that that separation of concerns is useful anyway in terms of design, in terms of architecture. And this is very much the key to driving designs, more complex designs from the outside in, using test doubles, using stubs and mocks and dummies, so that we can effectively define external dependencies without involving the real thing in the test, and so that we can define the interfaces of components that we haven't created yet that are further down in our core stack, another layer in the design, if you like, and then get to that later, but we can define it from the outside so it's guaranteed to be what we need. It's guaranteed to fit. Now, in the real world, what we tend to find is there is a mix and match of these approaches. We don't mock and stub everything, because then what you're doing, notice, is you're unencapsulating the internal design. Stubs and mocks come at a price. What we're saying in our tests here is that a library needs to speak to an info source and it needs to speak to an email system. Those are details of the internal design of library. So when we use test doubles, when we use stubs and mocks, we are unencapsulating some aspect of our internal design. So if you abuse them, if you overuse them by mocking or stubbing every dependency, every method that calls every method, and so on and so forth, you could end up essentially baking in the internal design into your tests. Your tests know too much about who's talking to who. So you need to kind of balance your approach here. So what I find works best for me is to chunk up your design into discrete components, if you like, the part that sends the emails, the part that fetches the information from IMDb, the part that knows who the members are, and so on and so forth. So you kind of break it down into not individual classes or individual functions, but you modularize it, if you like, into bigger chunks than that. Let's call them internal microservices, if you like. So an internal microservice might end up involving a number of classes, a cluster of classes, and a bunch of methods that all interact together that are about a specific responsibility, like sending an email or fetching information from IMDb. And that cluster of classes, that internal microservice, would have its own set of tests. So we don't have tests that refer to every method and so on and so forth. So we still drive our tests from the outside, but we also consider internal chunks, internal microservices, if you like, that have their own set of external tests. Let's call them internal APIs, if that helps. And these internal APIs will be very, very small, typically one or two methods, and all of their internal details will be hidden from the tests. So our sendMail method might be the only method that our library knows about in terms of sending mails. There might be a whole bunch of other stuff going on, but it doesn't need to know. We will hide that behind the sendMail method. Likewise, when we fetch information from IMDb, there might be a bunch of stuff that needs to happen, but all of those details, all of those methods, and all of those helper classes will be hidden behind that fetch info method. So we get many of the benefits of outside in design in terms of loose coupling between the parts of our system, the internal APIs, if you like, the internal microservices. But at the same time, we're isolating errors to a smaller subset of the overall code. So if it's all done entirely at the system level or the API level, the danger is that when tests fail, it could be 5, 6 layers down where it's actually gone wrong, and you're going to end up on a bug hunt basically trying to figure out where it's gone wrong. At the very least, we could know which component of the system, which subsystem, which internal microservice, if you like, it went wrong in. Now, just to finish off with an analogy here, I recently had a bit of a gas leak at my house, a very, very small one, nothing to worry about. But when the folks came to install a gas cooker, a new gas cooker, they discovered there was a drop in pressure measured at the gas meter outside at the front of the house. Now, the gas leak, as far as they could tell, was somewhere inside the house. That's literally all they knew. It's somewhere inside the house. If that were true, to find out where the gas leak was, we might have had to pull up floorboards and rip out plaster and so on and so forth to get to the gas pipes to figure out and isolate the leak. I was very lucky in the sense that it turned out that the leak was actually at the meter itself, so they were able to fix it outside the house. But it then occurred to me, if the gas leak was somewhere in the house, I would at least like to know which room it was in. And so wouldn't it be useful to have gas points, if you like, around your house where you could actually measure the pressure there to see whether the drop in pressure is between that room and that room. So you can isolate, is it happening in the kitchen? Is it happening in the bathroom? Which room is it happening in? You want a similar kind of thing with test-driven development. You don't want tests for everything, because when our tests bind to everything, you end up baking in the solution design. It becomes very, very difficult to change the internal design. But at the same time, you don't want tests that are all on the outside of the house, if you like. You would at least like to know what room the gas leak is in. So when a test fails, you'd at least like to know, well, it's the email part that's failing, or it's the IMDb part that's failing, so we can pin it down a bit more. Also, when we're constructing our solution, it is very, very powerful to be able to construct it one responsibility at a time, one job at a time, and to be able to fake the other parts of it whilst defining externally exactly what they're going to look like and exactly what will they do, using tests for the client code for those parts of the system. So test doubles, as well as allowing us to write fast-running unit tests that would normally have external dependencies, are a very powerful tool for scaling up test-driven development. They are very much the secret sauce to how do we make this work on real systems and real architectures. The answer is stubs and mocks and dummies, of course. So hopefully that's been of some use to you. There's a bunch of videos there. If you've not seen the previous videos, please go back and take a look at those. There's a link in the description below. And hopefully it's given you some ideas. The most important thing now is to try these ideas out for yourself. Try them out on these little exercises like the Mars rover exercise, and then try them out on your own projects too. And practice, 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 basically. I say this so many times with people. You can't just watch videos on TDD, you've got to do it. It's like riding a bicycle, basically. You can't learn it from a book, you can't learn it from a video. You have to get on the bicycle and learn to ride. So get TDDing. I wish you the best of luck.